Alright guys, this video is for Algebra 2. It's 8.2, adding and subtracting rational expressions. Okay, so the first problem here we have 3y over 2x cubed plus 5z over 8xy squared. Now, before we do this one, I'm going to put up something simple like, 2/3 plus a fourth. And, to do this problem, you have to, and without a calculator obviously, you have to get common denominators. And so you look at the numbers that in your denominator, 3 and 4, and we've always said, we're going to make them 12 because it's the first number that 3 and 4 go into. And so you do 12 here and 12 on the second one, and then you figure out, all right, well, if I'm going to multiply, what do I multiply by 3 to get to 12? I'm going to do that to the numerator 2. So you multiply 4 by 3 to get 12, so you're going to multiply 4 by 2 to get 8. And that's how you get from 2/3 to 8/12. And same thing here, that's 3, you add them up and you get 11/12. Well, that's all good. Same thing pretty much holds true whenever you move them into rational expressions, especially other ones like this. We want to figure out, we need to build these denominators. We need to build these denominators up to a least common denominator. So we're going to basically do it the same way we did with the 3 and the 4 and making them 12. Except now we're going to have more stuff going on. So we need the key. I'm going to say this a lot. This video is build the denominator up because you want to make sure that you move up to being the same thing. So the first thing you do is you look at your numbers. You have a 2 and an 8, and the first thing that those two numbers go into is 8. So your LCD number coefficient is 8. Now for your variables, remember you have to add to these. And we need to make them the same. So we have 3 x's over here and 1 x here. So the least common denominator that we need to build up to would be x cubed. Because remember, you can't take x's away from this one, so we have to add them to this one. Same thing with the y's. We have 2 y's here. We can't take these away, so we have to add them over here. So you have to build up. So your LCD is 8x cubed y squared. So from there, I'm going to show maybe a little bit of optional work as soon as you kind of understand what you're doing. But I'm going to write out 3y over 2x cubed. Leave a little space. Maybe just watch me do this one and then kind of follow along. Or 8xy squared. Now we're going to multiply these fractions by a form of 1. That'll give us the common like denominator. Okay, so your least common one. So for example, if you want to build this denominator 2x cubed up to being 8x cubed y squared, well, the first thing you got to do is get to turn 2 into 8 with multiplication. So that's going to mean multiply by 4. We already have the x's, but we're missing the squared y's. So we're going to put a y squared in there. And then what you do on the bottom of that guy, you're also going to do on the top, because remember, this has to be some form of 1. So 4y squared over 4y squared is a form of 1. And we're going to do that to the right-hand fraction as well. We're going to make this denominator look like this LCD. So 8xy squared to 8x cubed y squared. Only thing we're missing is an x squared. So we'll put that there and there. Okay, well, after you do that, you're going to multiply the numerators and the denominators together. So 3 times 4 gives you 12 y cubed over 8 x cubed y squared plus 5x squared z over 8 x cubed y squared, which builds them up to having them like denominators, common denominators. And now that they have common denominators, you can write this as one fraction. So 12y cubed plus 5x squared z all over 8x cubed y squared. You get like denominators. You put your numerators together as so. Okay, obviously you can't do any more with this because these aren't like terms. You can't cancel anything because you can't cancel anything in all 3 terms. So this term right here is your answer. Okay, so number 2, you have 3a squared over 16b squared minus the quantity 8x over 5a cubed b. I'm going to ask you for the LCD of these two denominators here. So the LCD of these two. Okay, so for this one, the LCD, you look it out, and I do recommend writing out what your LCD is like I do here. That way you know what you need to build up to. Is 80 a cubed b squared. Okay, so we're going to need to build both of these up to be 80 a cubed b squared denominator, so 3a squared over 16b squared. And to make 16b squared become 80a cubed b squared, you need to multiply it by 5a cubed. There you go. Minus the 8x over the 5a cubed b. And to get that to be it, we need to multiply it by a 16b. Okay, and then you do those multiplications, and then you put them together. You don't need to write the. I'm going to go straight to my answer now with this one, so I'll show you what I mean. Minus 128 bx all over 80 a cubed b squared. Okay, so you don't. Whenever they're monomials like this, you really don't need to show the step like last time where I had them separate out into 2. And then rewrote it into 1 over here. You can go straight from here to writing it as 1 over. Once again, no common term you can cancel out of all 3, so that's the final answer. Okay, so now sometimes they'll be a little bit bigger. We'll talk about your polynomials with this. And their LCDs, like I said, you got to build up to being the same thing. So the first thing you want to do with whenever you have polynomials is still factor everything just like last section. So we're going to factor x squared minus 6x minus 6, or x squared minus x minus 6, which is x plus 2 and an x minus 3, minus 4 over 5 taken out of there with an x plus 2. Okay, and the LCD for these is a little trickier to make. Like I said, you have to make sure that you build up your denominators. You can't take away from them. Okay, so you look at each term, and I always start with my constants first. So this one here has a 5 in it. This one has a 1. So we got to build it up to be a 5 first. So we put that 5 in there. We also have to build it up to being how they both have x plus 2's. Which is good, okay, but you still have to put that in your LCD. So it still has to be 5 x plus 2 in your LCD, even though they both already have 1. Okay, so this still needs to be in your LCD, because like I said, you got to build up to it. You can't take these away, even though they're in both. And then we have an x minus 3 here, so we got to build this one up to an x minus 3 with an x minus 3 as here. So your LCD is basically each individual factor as many times as it happens. So 5x plus 2, x minus 3. So now if you look, this first fraction here in the denominator has the x plus 2, has the x minus 3. The only thing it's missing is the 5. So we're going to multiply top and bottom by 5 on it. Okay, but I'm going to do this as one motion. So 5 parentheses x minus 1. The second fraction, and now we're subtracting these, so we're going to put minus next. The second fraction has the 5, has the x plus 2, it just needs the x minus 3. So the 4 that's there times x minus 3 that it needs, and this all over your LCD of 5, x plus 2, x minus 3. So you build up these denominators to be whatever your LCD is, which is in this case is 5x plus 2x minus 3. This fraction is missing a 5, so we multiply top and bottom by 5, which is right here. This one's missing the x minus 3, so we multiply it by x minus 3 with this 4 here. Put it underneath your LCD, or over top of your LCD. With these types of problems, there's typically a little more you can do. If you look here, there's a couple distributes you can do, and then typically following distributes are like terms. So that's what we have left to do here. 5x minus 5 minus 4x plus 12 all over the same LCD of 5x plus 2 x minus 3. And then you do like terms in the numerator. So you have two sets, so it should become x plus 7 over your LCD one more time of 5 x plus 2 x minus 3. Notice how these are all adding and subtracting, so your your denominator doesn't change on adding and subtracting, so you just have to be the same before you can do the numerators. Alright, so that'll lead us into the next one. You may see it as one question, or you may be able to see it as two questions. It's two questions that are coming up. Basically what I'm going to have you guys do now is do the same process and find this answer. Be careful with this trinomial here. Make sure you factor a GCF out of it first. The two questions are going to be what's the LCD? It's going to ask you that first, and then a few seconds later I'll tell you that answer to make sure you at least got the LCD right, and then it'll ask you for the what's the numerator's answer. Okay, so right now the first thing you need to do is find the LCD of 6 of the denominators. Okay, so hopefully we got the LCD to be 6, 2x minus 1, x minus 3. This one is the one I expected problems on. So if you look here, like I said before the question, you should have factored out a GCF of this guy, which is 2. Okay, so I'm going to do this work here in red. So 2, which leaves you with 2x squared minus 7x plus 3. And then to factor that trinomial, remember when you have a leading coefficient other than 1 on a trinomial, you want to do bottoms up factoring. So your multiplied number is the product of 2 and 3, in this case 6, and we want it to add to the middle, which is negative 7. So two numbers that multiply to 6 and add to negative 7. So x minus 6 and x minus 1, and then you divide them by the original 2 right here. And remember, if you reduce them, so if you can, so x minus 3, and then if you can't reduce, you bring it from the bottom up in the front, so 2x minus 1. So hopefully you remember that, how to do that. Now basically what the problem it's going to ask, the next question is going to be, what is the numerator in the answer? So when you plug that in, just put it in the numerator of the answer, because your denominator should be your LCD. So go ahead and put in the numerator for your answer on this question here. Okay, so hopefully in the answer you put in just the denominator, or numerator rather, 7x minus 2, and hopefully in your notes you have it over your LCD of 6, 2x minus 1, x minus 3. If you look here on the first fraction, you're missing the 2x minus 1, so you do 5 times it, bring the minus along. The last one here is a real trick one, because you have the 2x minus 1, you have the x minus 3, and you have a 2, but you got to make it 6, so you multiply it by 3 through here. Distributing, make sure you remember the negative sign from here to these two, and then just like terms. So 10x minus 3x to give you 7x, negative 5 plus 3 to give you negative 2. The last type of problem, there's 2 left for this video. I'm going to tell you, don't look in the book for these, because the book's way is way more complicated than what it needs to be. If you look at this is your complex fractions, obviously, and what they want you to do is just basically simplify these down to the point where it's a sum or a difference of a fraction that's not complex. So that's essentially what we want to do. And the way you do that is way easier than what the book is trying to tell you guys on how to do it. So what I'm going to ask is this. What you need to do is you need to look at the numerator, and I mean the big numerator, okay? Obviously, if you look at the big fraction, here's the big numerator, and then here's the big denominator. And if you look at the numerator and you figure out the LCD of the numerator, if you look at it, 1 is over 1, and then 1 over x. So the LCD of that numerator is x. And then if you look at the denominator, you'll see the LCD of between these two individual terms in the denominator, 1 and x over y, is y. So what the book wants you to do is they want you to do, x over x times x over x here, y over y times here. It's way simpler than that. What you're going to do for me is you're going to multiply the big fraction by that LCD combined, the product of that LCD, in this case, xy. And then you're going to distribute it into these two terms. So now you distribute backwards. So you have xy times 1, which gives you xy, plus xy times 1 over x, which gives you xy over x. And that's all over the denominators distributed. Xy times 1 gives you that xy, minus xy times x over y gives you x squared y over y. Now if you look at these two terms individually, you'll see there's cancellations you can do right there. So this x and this x, they cancel each other out, and the y's now in the second one cancel each other out, getting rid of your complex fraction. So that's how you get rid of the complex fraction with that one. So you're left with xy plus y over xy minus x squared. And that is your answer. The xy terms do not cancel out because once again they have to cancel out in every single term throughout. Okay, so that's the trick to that. The book, like I said, the book wants to make it a lot harder than what it actually is. So all you do, you just look for the LCD of the numerator, the big numerator, look for the LCD of the big denominator, put them together as a product, distribute it through, canceling as you go. So you got one more like that here. This one's your last question. Like I said, like I've said in the past videos, it's going to ask for the answer on the question coming up. Make sure that whenever you do so, make sure you put the division bar where it should be. Okay, so hopefully you have on your answer c minus d squared over d plus 6cd. Your cd is your least common denominator between these two and this one put together. Okay, so the least common denominator of the numerator is cd. Least common denominator of the denominator's terms is c, and so you build them up to be cd. Alright, that's how you do it. That's the end of the video, guys. Hope it went well. If you got questions, like I said, in class all the time, anything you need, homework for this guy is going to be page 541, 542, 19 through 39.